Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, we are going to be talking about dividing monomials. Yesterday, we talked about multiplying monomials, and we learned the product rule, where if you multiply the same bases, you keep the base and add the exponent. We also learned that when we raise a power to the power, okay, or in other words, we raise an exponent to an exponent, the power rule gets initiated. And the power rule states that when an exponent is raised to an exponent, you distribute the exponent to every single exponent inside of the parentheses. And today, we're talking about dividing, the quotient rule and the integer exponent rule. So it's pretty cool rules, pretty powerful, and let's do this. So the quotient rule, my brothers, states that if I have a to the m power divided by a to the n power, I'm going to get a to the m minus n power. So in other words, when you're dividing the same bases, keep the base and subtract the exponents. But please remember that it's the numerator exponent m minus the denominator exponent n. Please do not switch it around. Please do not do n minus m. Do the numerator's exponent minus the denominator's exponent, please. And we learned the power rule yesterday, and the power rule can extend to division. What the power rule states in division is exactly what it stated when we were multiplying. When I have a over b raised to the n power, I'm going to literally distribute this outside exponent to every single term or value inside of the parentheses. So this will become a to the n over b to the n. Okay? So when we divide the same base, you keep the base and subtract the exponents. If you have fractions inside of a parentheses and that is being raised to a power, I'm going to distribute that outside power to every single term inside of the parentheses. That makes sense? Because that's it. That's the lesson. Okay, well, half of it. And now, rules for negative or integer exponents. All right, check this one out, guys. If I have a to the negative m, that will equal 1 over a to the m. Why? Because what happens is when I go from numerator to denominator or denominator to numerator, I change the sign of the exponent. I'm not trying to be sarcastic, guys. I put an emphasis on the exponent because a lot of times people change the actual sign of the integer, and that's wrong. I'm going to explain. Oh, sorry. I'm going to explain real quick with just a little mini example. If I had, let's say I have 5 to the negative 2. That will equal 1 over 5 squared, right? However, if I had negative 5 to the negative 2, this will equal 1 over negative 5 squared. I did not change the sign of the negative 5. I changed the sign of the exponent, and only the exponent. Now, this is going from numerator to denominator. Well, guess what, brothers? Just like I said, if I go from denominator to numerator, I'm doing the same exact thing. So when I go from numerator to denominator or denominator to numerator, I only change the sign of the exponent. Now be careful, okay? Be very careful. Let me show you some pitfalls, okay? If I have 1 over 2 to the negative, actually, let's not do a number, let's do variables. Let's say I have 1 over x to the negative 3. That will equal x to the third. If I have 1 over negative x to the negative 3, okay. Now let's see who's really understanding this. Yes, sir. 1 over x to the negative 3. 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 1 over x to the nega Technically not. The negative 3 here, is this negative x in parentheses? So what will really happen is this guy gets brought up. So this will be x cubed over the negative 1 though. The negative 1 was not affected by that. Does that make sense, my brother? Do you see the difference? And then what if I did have in parentheses? Let's say it was 1 over negative x to the negative 2. Now this would be negative x squared over 1 because you brought it up. And then that would become x squared. Please be careful with those negatives and the exponents. The exponent only affects the value immediately to its left or everything inside of parentheses. Sir?
But what if his final answer be the same? Negative x.
In this one, it would have worked the same because it was odd. But that's why I went to even, because if it was an even exponent, it wouldn't have worked.
Yeah, but I'm saying if you're using a final answer as, wouldn't the final answer also be negative x cubed?
Absolutely, the final answer would have been negative x cubed. But I want to show them why. I wanted to point out that this negative is not being affected by that negative third exponent. In this case, so you're right, it would have been the same. But for example, if you did it like this here, it would have been wrong. If it was a squared, if that was a squared there, it wouldn't have been negative. See what I'm saying? Or actually, it would have been negative regardless.
Yeah,
in that case, because the negative's not being affected.
Yeah, but if you solve
right.
It's
Exactly. Thank you. That makes sense, guys? That's another hand here. All right, let's see. Very good. Very good question. So let's say I have 1 over negative 2 to the negative 3. This would equal 2 to the third over negative 1 because this negative 1 is not affected by that negative 3. Only this guy is. However, if it was 1 over parentheses negative 2 to the negative 3, then this would be negative 2 cubed over 1. In this case, they're both going to be the same answers. But I don't care about the answer. I'm caring about the procedure. I'm caring about the why did I get those answers. Does that help, sir? Does that make sense, sir? You guys good? Okay. May I continue, gentlemen? Thank you, gentlemen. So let's do this. Now, Mr. Morrow has a little bit of a different way of doing some things, okay? And hopefully if you pay attention, you're going to understand my madness. The technical way to do this, 6 to the 8 over 6 to the third, this is 6 to the 8 minus 3. It's the numerator exponent minus the denominator exponent, right? Which is 6 to the 5th power. And then I can go ahead and simplify that. I'm not going to do that right now yet. But everyone sees how I got 6 to the 5th power? Yes, sir. Did I skip the definition of zero exponent? I did? Well, that was weak. My bad. Sorry about that out there in internet land. My students are on top of it. Sorry about that, kid. Definition of zero exponent. A to the 0 equals 1. Anything to the 0 power will equal 1. Let's explain that. Because parentheses have a very powerful role here. 7 to the 0 is 1. But what's negative 7 to the 0? No. Is this negative being affected by that 0 exponent? So this is a negative 1 times the 7 to the 0, which is 1, which would equal negative 1. What if I said to you in parentheses, or how about this, 7x to the 0, what would that equal? This would equal 7, because x to the 0 is 1. That 0 is affecting the x, not the 7. Yes, sir. What's up? I'm sorry, Bubba? This guy here? The negative 1 is not getting affected by that 0 exponent. Only the 7 is. Correct. So it's negative 1 times 7 to the 0, which is 1, which is negative 1. Great question. Great question. What if I gave you this, though, in parentheses 7x to the 0? It would be 1, because everything inside of the parentheses is being affected by that 0. Everything is. So that would just be 1. Does that make sense, guys? Thank you for that, kid. Thank you. Sorry about that. So, if I got 6 to the 8 over divided by 6 to the third, the technical way is 6 to the 8 minus 3. Now, as we're going to see as things get more difficult and more complicated, you don't want to always have to subtract like that. It's going to take a lot of time when we get into crazy problems. And when we start working with negative exponents, people forget to do a double negative. And I'll show you an example in a second. So to eliminate all of those problems, I do it a little bit differently. I picture a set of numbers. How many 6's do I have in the numerator, guys? 8, right? So don't I have 1, 2, 3, 4, 5, 6, 7, 8, right? I'm not being sarcastic. Are you seeing this? 6 to the third. How many 6's do I have at the bottom, my brothers? 1, 2, 3. Okay, now, can't I do this? What am I left with? 6 to the fifth. Now, do you think I expect you to write out all these numbers always? No, but this is what I want you to visualize. So how do you put it together? How many 6's up here? How many 6's down in the denominator? Can't I take 3 of the 6's away to both top and bottom, and I'm only left with 6 to the fifth on the numerator? See how much easier that is? Yes, sir. I took 6 3's away from here and away from here. If I take 6 3's away from 8 6's, I've got 5 6's left. For this guy, the technical way is 6 to the 3 minus 8, which equals 6 to the negative 5, which equals 1 over 6 to the fifth. That's nice and simple, but that's going to become very tedious later. Very tedious. That's the real way to do it, the official rule way. I look at things differently. How many 6's do I have in the numerator? How many do I have in the denominator? So check it out. Can't I take 6 3's away from the numerator, leaving me with 1? And can I take 3 6's away from the denominator, leaving me with 5 6's? So I'm left with 1 over 6 to the fifth. Do you see how that is so much easier? And you don't have to do so many procedures. That makes sense, because remember, guys, I'm not doing this to make me happy. I want to make you guys happy. Does this make sense to you? Yes, sir. Okay, thank you. How many 6's do I have up here, my brother? How many 6's do I have down here? So can I take 3 6's away from the numerator? If I take 3 6's away from the numerator, I got to take 3 6's away from the denominator. What am I left with? 5 6's. Does that make sense? Sir, my brother. No, you have to put it as a fraction because you will never be able to leave answers with negative exponents. Yesterday, remember in the homework, I said you're going to have negative exponents, guys. Don't worry about them for now. In real life, you will not be able to use negative exponents. You've got to make them positive. Does that make sense, guys? We're going to walk before we run here. Now, okay, I got x to the fifth divided by x squared. Check it out, guys. Can't I take 2 x's from the bottom? If I take 2 x's from the bottom, I must take 2 x's from the top. Am I now left with x cubed in the numerator? B. Okay, I got 25 and 15. First of all, don't stress out. Reduce if you can. Can I reduce 25 and 15? Yeah, I can take out a 5, and I can take out a 5. So I know I have 5/3. The numbers are done. Now, I got 9 x's up here, and I got 6 x's down here. Can't I take 6 x's away from both top and bottom, and I'm left with an x cubed at the numerator? Yes, sir, my brother. Yes, you have to write specifically x cubed is the numerator because, and again, I'm not being sarcastic. That's where it is, in the numerator, my brother. You can't pick and choose where it goes. I can move the x cubed down if I want, but now it becomes x to the negative third. You have to keep it where it is. Unless it's negative, then you got to go up or down. Because whenever I go from numerator to denominator, or denominator to numerator, I change the sign of the exponent. Is it making sense? Okay. How about for e? I got y over 3 squared. So what does this remind you of? What do I have to do with this outside exponent? Distribute it. So this will become y squared over 9. Ding dong, the witch is gone. How about this bad boy here? What is this going to become? Negative 2 squared in parentheses because the negative 2 is being affected times y to the 4th because I want to distribute this exponent to every single other exponent over z to the times x to the 2nd. Can I simplify this? Yes. This will be 4 y to the 4th over z to the 6th x squared. Does that make sense, my brothers? What does 5y to the 0 equal, gentlemen? 5. Thank you. Just for giggles. Oh, no, it's over here. The giggles are over here. Okay, what about 3x squared raised to the 0 power? That's going to equal 1. Why, Moto? Well, the 0 only affects the y, not the 5. So this becomes 5 times 1, which is 5. The 0 affects every single thing here. So all of this gets raised to the 0 power. Anything to the 0 power is 1. Make sense? May I continue? Thank you, gentlemen. Okay. Now, I got 2 to the negative 3rd. How can I make this a positive exponent, gentlemen? Yes, sir. That's 1 over 2 cubed, which equals 1/8. Beautiful. Now, how is that different from this guy? Negative 2 to the negative 3rd. How is that different? If it's different. Talk to me. No. The negative 3 is only affecting the 2. So this negative 1 is not being affected. So it's negative 1 over 2 cubed, which will become negative 1/8. Talk to me, guys. I thank you for your honesty and for trying. Do you see where you made your error? Promise. Okay. How about this, guys? 4 to the negative 1 plus 2 to the negative 3. What? What does 4 to the negative 1 become? 4 to the negative 1 becomes 1 over 4. Guys, it's not negative 4. When you have a negative exponent, you have to either move it down or up. So 4 to the negative 1 equals 1 over 4. Plus 2 to the negative 3 equals 1 over 2 cubed. So that's 1 over 4 plus 1 over 8. Common denominator is 8, so that goes to 8, that goes to 2. So my answer here is 3/8, guys. That's the power of math. What's y to the negative 5th, gentlemen? No, it's not y over anything. Thank you. 1 over y to the 5th. Good job, brother. Now what's in parentheses negative y to the negative 5th? There it is, 1 over negative y in parentheses to the positive 5th, which equals 1 over negative y to the 5th. Because remember that when I raise a negative to an odd power, it stays negative. Now, how about this guy? Negative y to the negative 5th, but it's not in parentheses. Yes, sir. That's what I'm talking about. Excellent, brother. You only brought down the y because this negative 5 is affecting the y, not the negative 1. Excellent. You guys with me here? Okay. All right, now let's separate the men from the boys here. I want you to remember, what does this negative really represent? Really? So if you wanted to, it's a negative 1 times an x cubed over 4. This helps me a lot. It helps me recognize the negative. It helps me remember, hey, that -1 is there and it's valid. So this is what I'm going to do now. I'm going to distribute this -1 to every single exponent. So this becomes -1 to the -2, x to the -6, and 4 to the -2. But I cannot have negative exponents. So this guy's got to go up, and these guys got to go down. So this is going to become 4 squared over -1 squared x to the 6, which equals 16 over x to the 6. Please follow what I did. Please ask. Please ask anything you need. Yes, sir.
I feel like that has a lot of steps. I feel like it's easier whenever you see anything in parentheses to a fraction. Whenever you see anything to a negative exponent, you just automatically flip it and you keep the positive exponent.
You can. You can.
I feel like that's less steps.
You can. What the question was is this. If I have a negative exponent, okay, there is a law that allows you to invert or flip the inside without changing signs, but you can change the outside exponent. So you could do this. -4 over x cubed, +2 as the exponent. What happened? Whenever I have an exponent negative out here, I can flip these. Did I change the sign of the exponents though? Do not change the sign of those exponents. You can change this exponent though. Not you can, you have to if you do this method. So then -4 squared is 16 over x to the 6th. Either way is fine with me. And I was going to get to that next. It's just that, remember, I know that sometimes it feels like, wow, why does Moral go so long? I want to make sure you understand the nuances. I want to make sure you understand every single piece. But 100% you could do that. So let's do it over here for h. I've got -4x to the 4th over -3 raised to the -3. So let's go ahead and flip these guys. So I'm now going to have -3 over 4x to the 4th. I did not change the sign of the exponents, but I am going to change this sign. So now this is -3 cubed, which is -27, over 4 cubed, which is 64, and x to the 4th cubed is x12. X to the 12th. Does that make sense? Some people I found get confused with that. So some people have to do the long way. If you do, you can. It's going to be a -1 to the -3, a 4 to the -3, an x to the -12, and then a 3 to the -3. And then you can calculate from there and change the signs. So really determine what works for you and master it, in my opinion, gentlemen. Does that make sense, guys? All right, last but not least, let's just knock it all out. Everything together now. Now I have a little bit of multiplication with division with power rules. So now it's a little bit of everything. Now, can you guys see here right off the bat that you got some positives and some negatives, right? My suggestion, strong suggestion, is to make all the exponents positive first. So first of all, let's first talk about the numbers. So I got -27 over 18. What can I take out of both of those? 9. So I'm going to have -3 over 2. Okay, that's done and that's done. Now, you see how I have a to the 7, but I have a to the -2. How do I make that a to the -2 a +2? No, how do I make this a to the -2 a to the +2? Thank you. So I have a to the 7 times a squared because I brought it up. Now this b to the -6, how do I make it positive? By bringing it down. So now I have b squared times b to the 6. Now I have everything positive. Now I can rock and roll. So I got -3 halves. A to the 7 times a to the 2nd is a to the 9th. b to the second times b to the sixth is b to the eighth. Now, I see a few of you going, oh my God. No, think about it. If you go the longer way, it's going to be way more difficult. If you go the longer way, whoa, that was kind of cool. If you go the longer way, this will still be negative 3 halves. Now, check it out. Now you'd have to go a to the 7 minus a negative 2. Are you really going to remember that minus a negative 2? Odds are you won't. Not because you can't or not because you don't have the ability. You're going to be nervous. You're going to be trying to rush through it. That's why I always strongly suggest make the exponents positive first. Then simplify, multiply, divide, whatever you got to do. Next, I got 3 halves a cubed b to the negative 2 times negative 12 a to the negative 4 b to the 5th. I'm going to make all of my exponents positive. So this is going to become, you have 3 halves, a to the 3rd stays, but this guy has to go down. So this becomes b squared. Do you see what I just did there? Do you see what I just did there? Then I have over here, negative 12. Now a to the negative 4 I got to bring down, so that becomes a to the 4th down here, positive, b to the 5th. Now that I have positive exponents, now let's rock and roll. I can take this, it's a negative, so that's going to be negative 18. Now, check it out, guys. I have 3 a's up here, right, and 4 a's down here, right? So can I get rid of these 3 a's, get 3 from here, and I'm just left with 1 a in the denominator? Do you see that, guys? Do you see that, guys? For the b's, don't I have 2 b's here and 5 b's up here? So can I get rid of 2 b's from the top, from the bottom, and 2 b's from the top, and now I have b cubed left over? Do you see this, guys? It's making sense, my brothers. We're running out of time. Okay? Now, how about this guy? I got negative 2/5 m to the negative 2 n to the negative 1 times negative 15 halves m n to the 0. Let's simplify everything first before we multiply. So this here is a negative 2/5, okay. M to the negative 2, I'm going to bring it down. N to the negative 1, I'm going to bring it down. So this becomes m squared n in the denominator. Times, I got a negative 15 over 2. N to the 0 is 1, so I just got an m here. Now, you ready? Because here's the magic. 2 goes into negative 2, negative 1 times. 5 goes into 5 one time. It goes into negative 15, negative 3 times. I can get rid of 1m in the numerator and 1m in the denominator. And I'm going to be left with 3 over mn. So, my brother, thank you. Come again, my brother? Yeah, it is a negative 3, but a negative 3 times a negative 1 is a positive 3. Sir. Thank you, sir, for caring. Does that make sense, gentlemen? Okay. How about this bad boy? I got a negative 2 here on the outside, right? And I'm going to flip it, but do you see how I have negatives already in? Okay, sorry about that, guys. Okay, so before I'm going to switch the insides here, guys, I like to make my life easy. I'm going to simplify things. So I'm first going to say, okay, 5 goes into 25 5 times. 5 goes into 10 2 times. So I've got 5 halves. I'm going to bring this a down. So I've got a times a squared, so this becomes a cubed. I'm going to bring this b up. So that becomes b times b, which is b squared. Now it's all raised to the negative 2. Now let's go ahead and flip it. 2a cubed over 5b squared to the positive 2 power. Because when I flip these inside, I do not change the sign of the inside exponents, but I do change the sign of the outside exponent. So now this will become 4a to the 6th over 25b to the 4th. Does that make sense, brothers? Talk to me, my brothers. Okay, now, you've got 2 left. Please, this is not a request. This is part of your homework. I'm going to check this tomorrow. Please complete E and F in addition to your homework. May God bless you. Thank you so much. Hope you learned a lot. Thank you for a great class. Bye-bye.